In Statistics Lesson 7.3, we're going to learn how to use the StatCrunch to help make our homework assignments a little bit easier at this point. But before we get started, I do need to have you understand that the idea on this lesson today is if we're given a set of data, it might not have come from a normal data. We don't know if it did or not. And so we have to be able to test for that, especially when we have small sample sizes. If you have sample sizes of over 30 and you're talking about the means, really, we don't have any much problems with it. For some reason, 30 seems like the magic number. But when you have less than 30, you need to test if the data was from a normal population or not, if you didn't know if it was originally. What you do is you end up graphing on the x-axis your original x values, your values that you've collected, and your y-axis, which you traditionally would think of as x-y-axis, your y-axis actually now becomes the z-scores, or we call the normal scores. So for this first question here, number 1, when it asked us to, a blank is the graph that plots observed data values. Okay, so the blank is the graph that plots observed data values versus the normal scores. And this is what we call a normal probability plot. Now, in the StatCrunch system, for some reason, they call that a QQ plot instead of a normal probability plot. It used to be called a normal probability plot in StatCrunch, and I'm not sure why or when that name was changed. And so that'll be your answer to number 1. All right, so number 2. All right, we are given a lot of different data values here. These are the graphs, and we need to see this. If you notice these x-axis, these are the observed values. Let me zoom in on these for a minute. Okay, so all of these say observed values for these x-axis, and all of these y's say the z-scores. So the z-scores or expected z-scores are from -2.5 to 2.5 with the observed values from 1,000 to 1,600. Well, I'm going to click here, again, like the where the mouse is, I'm clicking here for the chocolate chip data. These are all the data values we're talking about. Now, that'd be a lot of numbers to be typing into my calculator. We could do it, but it would definitely not be worth the time. If you work for me for a corporation at this point in your game, I would hope that you would know how to use the StatCrunch, which is a big time saver for you in statistics. So I'm going to back this up a little bit because we're going to need 2 screens here in a few minutes. All right, I'm going to take the homework part over here to the left a little bit. All right, on the data value one, there's this little square right there. I'm going to click on that square, and I'm going to tell it to open in StatCrunch. So what it's just done is it opened in a new window. And if you're at home doing this on your computer for the very first time, you might have to enable the pop-ups from this new site here for StatCrunch. All right. So as I take a look, all my data values are right here in a column. Okay, I'm going to call on that. The title of this column happens to be called variable 1. So I want to get a graph. So I'm going to go to the word graph. So let me kind of zoom this in. So I'm going to click on the word graph right here. Now I'm going to choose the QQ plot. And again, like I said, I'm not sure why StatCrunch calls it a QQ plot, but it is really a normal probability plot. That's your observed values for x's, your expected z's for the y's. All right, so normal QQ plot. Now, remember we just said a minute ago that my data happen to be right here in column 1. So I'm going to choose var1. That means that's the column all my variables are in. I'm going to go down here to where it says add, and I'm going to add correlation statistic. I'm also going to add the normal quantiles on the y-axis. See, I want those z-scores plotted on the y-axis. All right. From there, now let me zoom back out. I then choose this button right here in the bottom right that says compute. So I tell it to compute. And here's my graph. So I'm going to take this over to the right a little bit. I'm going to keep that graph right there. And I'm going to use this right here. Now, notice we need to figure out which of these multiple choice graphs is going to match that. It's obviously not B. B is in a perfect straight line. My graph is not in a perfect straight line here. So I know I do not want to use B. All right, so from there, I'm going, okay, does it kind of look like this one? Do my points look like they're in these little clusters? No, it doesn't look like that either. And if you notice, you do have a z-score down here at -2. And this one has z-scores only going as low as about -1. So therefore, I believe my answer is going to be D. So again, I looked there at the z-score, went down here to about -2 on this one, up here to about a +2. That's why I knew graph A was out. B was out because that's not a perfect straight line. C was out because I didn't have a bunch of cluster points. All right. The next part says it wants the mean, and then I'm going to go ahead and tell you it also is going to want the standard deviation of this data. And now, again, I said I was trying to show you guys some things to save you time, so you're not spending forever typing in all those data values. So if I come back over here, I'm going to come back to this window again. Sorry. All right, I'm going to go ahead and close this graph. All right. Now, all my data was in this column. Okay, it was all in column 1. So I'm now going to go to the button Stat. Okay, actually, let me move this over. Let's zoom in again. That's hard to read those buttons. All right, so I'm going to choose the word Stat. I am going to go to Summary Stats. My data is in a column. Okay, so need to move that over since I'd zoomed in. So again, I went to Stat, I went to Summary Stats, and my data is in a column, so I'm going to choose Column. Now, what column was my data in? If you remember right, that column was labeled var1. So I'm going to click that. When I clicked it, notice it put over here in the white box. That's the column it's going to use the data from. Now, down here in this little gray box right here, which is statistics, I know I want the mean of the data. Notice it just put the mean over here on the right. Then I'm going to hold the word control, and I'm also going to push standard deviation. Notice it just put mean and standard deviation over here. So again, I clicked on the variable 1. That's what the column it's in. I chose the word mean. I chose the word standard deviation. Holding the control, when you push standard deviation, it allows both of those to move over. And then at the very bottom, I'm going to choose the word compute. Compute. So I choose that word compute. There's my mean, and there's my standard deviation. Pretty nice, huh? So I'm going to take this, I'm going to move this back over out of my way so I can come back to the homework problem. I'm also at this point going to go ahead and zoom back out for the homework, back in. All right, so now I can go answer my question. It says, what's the mean, but to 1 decimal place. So 1301.8. So there's my mean. My standard deviation to 1 decimal point. So 119.8 on this situation. All right, we're going to use that mean and the standard deviation for part C, D, and E. So that's why if you notice, I am keeping my little box here with my mean and standard deviation because I'm going to need that again. All right, so problem C wants me to pick the normal curve because, see, our data kind of followed a linear pattern in that first graph, so therefore we're assuming our data is coming from a normal population. Okay, it's somewhat linear, so our data is probably from a normal population with a mean of this and a standard deviation of that number. Well, I go down here and I need to find which graph has a mean of about 1300. See, this mean for graph B, for my graph B, let me make B a little bit larger here. That mean is at 1200. I don't know if you can see that, but that is 1200, so that's definitely not my answer. The mean for graph C, that's above 1400. Definitely not my answer. Again, I'm looking for a mean of about 1300 here. See, so those two graphs are out. So I know I can get rid of those two. Again, that mean there was 1200, so bad graph. Okay, graph C was bad as well. Alrighty, so we get rid of those two. So I'm now down, I need to make this larger. All right, I'm down to graph D or graph A. And again, I need the one where the mean is about 1301.775, a standard deviation of 119. So if I take a look at the count here from 1200 to 1500, so I might want to just go ahead and make that one larger for a minute. That's 1, 2, 3, 4, 5, 6 boxes to get there. 6 boxes to go 300. Well, that would mean every 2 boxes would be another 100. See, that would be 1300, 1400, 1500. That right there is just, looks like to me, just a little bit shy of 1300 or like right on 1300. Let me go take a look at this other graph and let me see what we've got here. So from 1000 to 1400, again, that would be, looks like 1200 to me, 1100, 1200, 1300. That's definitely not it. So again, they were counting by 50s on that axis. So therefore, I knew this one was graph A. So again, all I was looking for was the mean, which one has the mean and about in the middle for the value that you're supposed to have. Now, part D and part E, these are really good questions. These are going to take you back to stuff that we did in our last chapter, which actually, I'm sorry, the last section or two that we have been working in here. Now, remember for this problem here, we were given a mean of 1301.8. Okay, that was my sample mean. My sample standard deviation was 119.8. Now, we're being asked for the probability that this bag of chips has at least 1,000 chips in it. So when we're asked that, that means I need to go ahead and get that z-score. So this is what we're being asked to do, like we did in the last couple sections. Again, so I had the sample mean is 1,000, basically 1,301. The standard deviation, 119.8. Probability that we have at least 1,000 chips. So I'm looking for this z-score, and once I get that z-score, that's when we did the normal CDF from that z to 100. Because remember, guys, once you get that z-score, that's going to tell you on a standard curve where the mean is based off of 0 and standard deviation based off of 1. So to get your z-score, you take your 1,000, you take your x value minus your mean. You divide that answer by your standard deviation. So we're looking for a z-score here of negative 2.5192. Yeah, I'm going to draw a little picture of this here real quick. Just give me a second. Negative 2.5192 and greater. Okay, so here's kind of the picture of that. So again, I took the 1,000, okay, minus this mean, sorry, it's blurry, divided by the standard deviation. That gave me the z-score, so it was a negative z-score. So I wanted greater than that, so therefore I do know this answer should definitely be more than 50%. And again, like I said, then you would do second distribution. You would do a normal CDF of negative 2.5192 for your lower bound, your upper bound of positive 100. Leave it 0 and 1 for your mean and standard deviation. And therefore then this answer should be, it says it wants it to 3 decimal places. So my calculator, I got 0.994 on my calculator. Okay, and let me show you with the calculator on that. Okay, now, come on, zoom in on this. Trying to get the, there it goes. All right, so the top one showed you the x value minus the mean. Second one divided by the standard deviation. The third one was my normal CDF from that z-score to 100 since I wanted greater than the 1,000 chips. All right, the next problem on this says it wants to use the same normal curve, but this time I want to know the probability that a random bag would contain between 1,200 and 1,400 chips. So again, this time I want the random bag to contain between 1,200 and 1,400 chips. Now remember that the standard deviation was 1,300. The mean was 1,300. Let's just assume it's 1,300 for a minute for sake of talking about the problem. All right, so that was my mean. Now I want the bag to have more than 1,200 chips, between 1,200 and 1,400. So that means I should have a negative z-score and I should have a positive z-score. See, the left one was the 1,200, the right one was the 1,400, and I'm looking for the probability that the chips are somewhere between that. So this is what I'm looking for. See, we know the mean was the 1,310.8. I want to know the probability that the bag contains between 1,200 and 1,400 chocolate chips. This will be a negative z-score. This one would be the positive z-score. Remember, these are my two x values that I have. So I'm going to have to calculate each one of those z-scores. Remembering here that our mean, our sample mean was 1,310.8. Our standard deviation, that's why I had that little box still sitting over here, because we need to refer to that, 119.8. So I need to get each one z-score. So I'm going to have to take the 1,200 minus the mean and divide that by the standard deviation. Okay, I'm going to do the same for the one on the right, except now I'm going to use the 1,400 instead of 1,200. I'm going to show you this on the calculator here in just a second. Okay, so the bottom two lines are getting those two z-scores. So 1,200 chocolate chips minus the mean, the 1,300, divided by the standard deviation. So it had a negative z-score of negative 0.92. The 1,400 chocolate chips, take away its mean, divided by standard deviation, gave me that positive z-score of 0.74457. Now remember, I would want to do a normal CDF between those two z-scores. That's how I will get the probability that a random bag would have between 1,200 and 1,400 chocolate chips. So I'm going to finish off this picture real quick, and then I'll do the normal CDF, and I'll show that to you on the screen as well. So 0.9249. The other z-score was 0.7446. And I'm going to do a normal CDF. So give me just a second. I can't, if I work these out ahead of time, the numbers change on the computer when I go to input the numbers for you guys to show it as a video. So sorry that this is kind of having to wait for me to write. All right, so there was the two z-scores. So I want the normal CDF between those two z's. That would give me the area between those. That would give me the probability that a random bag would contain between 1,200 and 1,400 chocolate chips. The only thing I don't like that I did on this picture is I wish I would have put an X on that line where the 1,200 and 1,400 are. And I'm going to add that real quick. Okay. So here's what I was talking about. I really should have put an X right here because these two values, 1,200 and 1,400, represent the X. These values down here below actually represent the z-scores. And remember, that's then when I go to the calculator and I do my little normal CDF between those two z-scores. So the negative 0.9249 and on the right side 0.7446. That gave me a probability of basically 59.42% chance of grabbing a random bag of chocolate chips and it containing between 1,200 and 1,400 chocolate chips. So this answer is supposed to be to 3 decimals, so 0.594. So 0.594. Uh-oh, that was not correct. Okay, 1,200 to 1,400. Where did I mess up? 446, 0.9249.7446. Three. Let's try. I'm going to try taking this to a 3, and then I'm going to take it to a 5. I know our concept's right. I think it has something to do with the rounding errors. So I apologize for that. There we go. I would have overridden that on a test. This is paper and paper pencil test anyways. So really that should have been a 0.594 right there, being that we took our decimals. It was that I took my z-scores to 4 decimals, and I have a feeling they took their z-scores to only 3. All right, I need to close these graphs for the last problem and that mean and then the StatCrunch. So I'll close it entirely. All right, they're even telling you to open the data set in StatCrunch, left click on the icon next to the data set. So we're going to get there in just a second. All right, so this one's saying, here's all my data values. This is the O-rings was obtained from a wall thickness in inches of each one was recorded. Use a normal probability plot. Remember in StatCrunch, that's called a QQ plot, to assess whether the sample data could have come from a probability that's normal. So we're going to, all right, I'm going to zoom in again. All right, so we're going to click on this little square. Okay, again, I left click, I open in StatCrunch. All right, I want the graph this time. Okay, so all my variables is right there in column 1 and as var1. I want the graph. I want the QQ plot. So I'm going to choose QQ plot. All right, my data is in column 1, which is called variable 1. I'm going to click on correlation statistic. I'm going to click on normal quantiles on the y-axis. That means that's going to put the normal z-scores on the y-axis for me. And at the very bottom, then I'm going to choose the button compute. Compute. So it's going to compute that for me. All right, so we're going to need this correlation to be able to determine if our data come from a normal population or not. So I'm going to just slide this over here for a little bit, for a minute. So I need this number here, this correlation 0.997. If that correlation is greater than my critical value, then we may assume our data comes from a normal population. If that correlation is not greater than the critical value, then we do not know if the original population was normal or not. We wouldn't know. So what I need to do, my critical values are going to come from, okay, I'm going to go here to this table. Let me zoom back out a little bit. There we go. All right. So where I'm at is over here. I'm going to click on, it says click here to table of critical values. So I'm going to click on the critical values. Now, how many points was in my data set? That's what I have to determine. There was 4 by 4, so there's 16 data points here. So I have to go to sample size of 16. That critical value is 0.941. So my critical value was 0.941. I'm writing that down on a piece of paper. My correlation from my graph here just a second ago was 0.997. Now, here's what I was saying to you a second ago. If the correlation is greater than the critical value, then we may assume the data comes from a normal population. So our correlation is 0.997. That is greater than the critical value of 0.941. Therefore, we may assume the data comes from a normal population. So when I go to choose the right answer here, all right, I'm probably going to move this over a little bit, and, well, that did not do what I wanted. Okay. This thing's acting crazy. All right, I want to look at these 4 multiple choice down here. All right, so first off, it says a no. Well, yes, we are saying this is from a normal population, so it's either C or D. All right, so I already know I'm down to C or D at this point. C says the correlation between the expected z-score and observed exceeds the critical value. So far, they both say the same thing. Then the second sentence says, therefore there is a reasonable to conclude the data comes from a normal population. And if you look at D, it says, therefore it's not reasonable to conclude it comes from a normal population. So I do need to choose answer C. First one here is about the correlation. So the correlation we got from the graph of 0.997. The next one that says exceeds the critical value came from the table of 0.941. And that was finished then. So again, as provided that the correlation is greater than the critical value, then you may assume the data comes from a normal population. Okay, the correlation comes from the graph. And when you look at your graph, guys, it says it right there, correlation. It says correlation right here on the top of my graph. So there's no doubt as to which one was your correlation. And then your critical value actually comes from the table. And that table says critical value right here. So this should make this pretty simple. This is how you do number 3 and 4 in this assignment. Hope this helped you guys. Have a great day.